Well, now we're going to do question 10. The question says that the number of molecules of a certain drug in the bloodstream T hours after it has been taken, it is represented by the equation that is given m of t. And then question 10.1 says determine the number of molecules of the drug in the bloodstream 3 hours after the drug was taken. Well, I'll write a question here, 10.1. It is given that m of t is equal to negative t cubed plus 3t squared plus 72t. I think I have to move my board a little bit this way. Plus 72t, okay? You can just keep it. I think I have enough space. And then it is also said that t is in between 0 and 10. Now, question 10.1 says determine the number of molecules of the drug in the bloodstream 3 hours after the drug has been taken. This precisely simply means calculate. Okay, we are asked to calculate m of 3. This is what we are asked to do. Now, when I say m of 3 will be equal to negative t cubed, okay, plus 3t squared plus 72t, okay. We sub in the value of t by 3, 3, and 3. Now, this is equal to, we can just sub it in the calculator, because this will be like negative open brackets, 3 close brackets to the power of 3, okay, and then plus 3 t squared, so 3 there squared, and then plus 72 open brackets, 3 close brackets, okay, yeah. So when we hit equal, this is equal to 216. So there are 216 molecules, okay, after 3 hours. And then question 10.2, that was 10.1. Now 10.2, the question says, determine the rate at which the number of molecules of the drug in the bloodstream is changing exactly 2 hours after the drug has taken. So now when we talk about the rates, it means we are asked to calculate the derivative of a function m, okay? So over here, to determine the rate, it simply means find f of t, m prime of t at the point, at the time t is equal to 2 hours. So this will be then, first of all, m prime of t will be equal to, okay, I'm looking at mt over here, okay, so mt will be equal to negative 3t squared plus 6t plus 72, okay, then m prime of t will then be negative 3 f prime of 2 now. Maybe I can just take, let's send the brackets. Okay, I cannot, I'll leave it there. Inside the bracket, I meant to write 2. So over here, it's actually 2. Okay, there it was bracket. So we sub in negative 2, wherever we see t. So it's going to be negative 3t squared plus 6t plus 72. So we sub in 2 and 2. And then in the calculator here, we're just going to write negative 3 open bracket 2 close bracket squared. Okay, and then plus 6 open bracket 2 close bracket sorry, we have like -3, open bracket, 2, close bracket to the power of 2, and then plus 6, open bracket, 2, close bracket, and then plus 72. Okay, when we hit equal, and then we get the answer here, this is just equal to 72. So this is just 72. So the rates will be, I'll say 72 molecule per hour. Okay. Now, question 10.3, that was question 10.2. Question 10.3 says, how many hours after taking the drug will the rate at which the number of molecules of the drug in the bloodstream is changing be a maximum? So when we talk about the maximum here is when we're going to set the derivative of this function mt equal to 0 to determine the maximum. Okay, so now I'm gonna move this. So 10.3 could be, so we are asked to calculate mt of 0, but we are actually asked to find t. Now we're going to, the derivative was calculated already previously. We got like -3t² plus 6t plus 72. We're going to set this equal to 0. Over here, we're going to divide each term by 3 because they're all multiple. I prefer to divide by -3, okay? Because I want to get rid of the negative in front of the t². So this is going to be t² minus 2t, 72, that makes -24 equals 0. Now, I'm going to take here, if I need to factorize, I'm going to take 24. The fact it's -24. The factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now, over here, if I want to look at the factors, okay, wait, now write t, I meant to write t here, and then t there. Okay, I'm going to look at the factors of 24, which will make a sum equal to -2, that -2 here, and then a product -24. So this will be then, if I look at here, okay, this will be then, okay, it's going to be +4 and -6. So +4 here and -6 there, and then over here that makes t will be equal to -4 or t will be equal to 6. So after 6 hours, it will reach the maximum. All right, hold on a second. The question says this. The question didn't tell us what should be the max, after how long we're going to get the maximum. Of course, if we work out for the maximum, we're going to get it. The maximum will occur when the time is equal to 6 hours, because this is not applicable. But now the question didn't say, the question, we're not looking for the maximum. If I look at the question here, they said, how many hours after taking the drug will the rate of the rate at which the number of molecules of the drug in the bloodstream is changing be the maximum? Now we're talking about the rate, that the rate of change will be the maximum. I don't know if you get my point. Not that this function in the maximum, but the rate of change be the maximum. This means we're not going to make the derivative equal to 0, but rather the second derivative is equal to 0, because the derivative is given by this. Now the second derivative to find the maximum rate of change, not the maximum of the function, but the maximum rate of change. So we're going to work out m, second derivative of t. This will be equal to -6t plus 6, okay? And now we're going to set the rate of change equal to 0. So we have like -6t will be equal to -6, and then dividing both sides by -6, okay? We will have t will be equal to 1. So the rate of change will be the maximum. The maximum rate of change occurs when, which in other words, the point of inflection occurs when after 1 hour. Thank you.